In the last section, we added a little bit of error handling code to our new deck from file function. Again, this function style right here, or this kind of little setup where we are checking to see if this error object is not equal to nil, is a very common pattern that we're going to see around error handling many times in a lot of different Go programs. So back on track. At this point, we've got presumably some value within this BS, or byte slice argument. And so we spoke a little bit about byte slices previously. We had said that whenever we see a byte slice, we can really think of it as being a string. And so now we're back into a very similar situation to what we had before, where we had a deck, we wanted to turn it into a string slice, turn that into a string, and convert it to a byte slice. So now we're doing the exact opposite. Now at this point, we have, frozen up here. There we go. At this point now, we've got a byte slice. We're going to turn that into a string, turn that into a slice of strings, and then turn that into a deck. And so to be 100% clear, the byte slice that we're working with right now is a byte slice that represents every single character in our playing card list, and each playing card is separated by a comma. Let's try to convert this byte slice into a string, and then we'll log out the value of that, and we'll get a better sense of exactly what we're working with here. So back inside of our new deck from file function, at the bottom, we're going to add in a reference to byte slice, and we want to turn this into a string. So we're going to say we have a byte slice and we want to turn it into a string. So again, a little bit of type conversion here. String is the value that we want to have, and we place in the value that we do have. So now this is represented as a string. So if we wanted to, we could print out the value right now, and we would expect this to be something like ace of spades, comma, 2 of spades, comma, 3 spades, and so on. You get the idea. So remember how we originally joined all these playing cards together? We used that strings package. And so again, as you might imagine, we're doing essentially the exact opposite of what we did in Save to File. So we're going to again use that strings package to take this string and separate the string by all the commas inside of it. So let's pull up the documentation around that strings package again. I'm going to go back to my documentation. I'm going to go to my big list of all the different standard library packages. I'll search for strings. Here it is right here. I'll look at my list of functions inside of it, and one of the functions inside of here is split right here. So with split, we pass in the slice that we want to work on. The string that we want to work on, my mistake. I don't know why, but they kind of didn't really complete the documentation here. S is supposed to be the string. They didn't actually label the type on here, but whatever. Then the second argument will be the separating character that we want to split by. So for us, it's going to be a comma. And then back from this, we'll get a slice of strings, which we can then use to turn into an actual deck. So let's give it a shot. Back inside of our deck.go file, I'm going to take the string that was generated by this type conversion right here, and we'll pass it into strings.split. So this is the string that we want to attempt to split, and we want to attempt to split it by the comma character. We'll take the value or the output of this right here, which is essentially going to be our slice of strings, and I'm going to assign it to a variable of s. Now I know these single letter variables are really not the best thing in the world. I know they get confusing very quickly, but again, this is really convention in the language. You're going to see a lot of very short variable names. And so it's kind of us to kind of interpret this and say, okay, strings.split, that's probably going to return a slice of strings. Yeah, I guess s is a reasonable variable name, short for slice of strings, or just slice. I guess technically we might call it ss for string slice, but s is just as good. And then the last step is to turn this slice of strings into an actual deck. And so to do that, we will again use a little bit of type conversion. So we're going to list out the type that we want to have, and we're going to pass in the type that we do have. So we want to get a deck, and here is a slice of string. Now again, the fact we are only able to do this little conversion right here, because remember, the deck type that we created is really just sitting on top or extends or kind of an alias for a slice of string anyways. And so it's not a real big stretch of the imagination to picture the fact that we can take a slice of string and turn it into a deck. Really, when we turn the slice of string and turn it into a deck type, what we're really doing is saying, hey, here's a slice of string, here's a bunch of functions that we can now use with this slice of string. That's another way of picturing it. Okay, so right here we turn these slice of strings into a deck. So the very last thing to do is to make sure that this function actually returns that value, or actually returns the deck that we just created. So we're going to make sure that we return that value. All right, we'll save this file, and I think that we're at a pretty good place for testing this out. So I'm going to go back to my main.go file. You'll recall that we had previously created a deck and saved it to a file called my_cards. And so I should still see in my project directory the mycards file, and here it is right here. So now we'll say get rid of all that, and instead we'll make a new deck of cards, and this new deck of cards is going to come from a function called to new deck from file, and then we'll make sure that we pass in as a string the file that we want to attempt to load, which is my_cards. So my_cards. And then, hey, let's just print out the deck of cards. So we'll say cards.print, like so. Okay, time to test this out. I'm going to flip back over to my terminal. We'll do our go run main go and deck.go files. And we get out our print of all of our cards. So this is looking pretty good. Now, the last thing I want to do really quickly is to see what happens if I attempt to load up a file that does not exist on my hard drive. So what happens if I try to load up a file called my? Well, let's save this. We'll run the file again inside of our terminal. And now this time around, we get this really clear description of what just went wrong. So we get error, so that's the string that we passed in that said error:, and then the actual error that occurred. So we attempt to open a file called my, and no such file or directory exists, and then we get an exit status of 1, which indicates that something went wrong when we exited the program. So it looks like we are correctly handling the error case here when we attempt to load up a file that doesn't actually exist. Okay, so I think that pretty much closes out our new deck from file function. I think this is looking pretty good. I think that we've got one big function left, which is our shuffle function. So let's take a quick break. We'll continue in the next section, and we'll start to figure out how we can shuffle all the cards inside of a deck. So I'll see you in just a minute.